Let us see I/O port interfacing in microcontroller subject. Myself, Miss MAMTA WANJRE, E&TC department from AISSMS, Institute of Information Technology. First, let us see the introduction of LED. LED is a light emitting diode having two terminals. Two leads are there. It is a semiconductor light source. It is a p-n junction diode that emits light when activated. When a suitable voltage is applied to the lead, electrons are able to recombine with electrons holes within the device, releasing energy in the form of photons. This effect is called electroluminescence, and the color of the light corresponds to the energy of the photon is determined by the energy band gap of the semiconductor. When operated in the forward bias direction, light emitting diode are semiconductor diodes. In that light emitting diode, its colors, different colors are there, that is available in different colors, that is red, infrared, amber, yellow, green, blue and white, depends upon different wavelength and its forward voltage. LED, whenever you connect LED to microcontroller, LED series resistor is also required, that is connected with LED. The series resistor value RS is calculated by simply using Ohm's law. By knowing the required forward current IF of the LED, the supply voltage Vs across the combination and the expected forward voltage drop of the LED, that is Vf, at the required current level, the current limiting resistor is calculated as, suppose amber colored LED is connected, we use with a forward voltage drop of 2 volt is to be connected to a 5 volt stabilized DC power supply. Using the circuit above, calculate the value of the series resistor, and for that 10 milliampere current we consider, that is a forward current, and from that we have to calculate the series resistor using that formula, that Vs minus Vf divided by Rf, that is current flowing through, that is IF. So 5 volt minus 2 volt divided by 10 milliampere, and that value is 300 ohm. Then let us see how to interface LED with 8051 microcontroller. An LED can be interfaced with 8051 for various purposes. The port in the output direction. So once the logic 1 is the at output pin, then an LED will be turned on, and when logic 0 is there, means LED is turned off. Simply logic 1 means 5 volt supply is there, that is the output port, that is the output pin, and whenever logic 0 is there, means 0 volt is there, and that is given to output pin of 8051 microcontroller. So as to discuss in earlier, the LED with common cathode mode can be connected with 8051 along with a resistor, that is a series resistor. Thus, using the current limiting resistor, the LED will blink according to the written program in 8051. Below the diagram that is shown below, in that port P1 having 4 pins are interfaced with LEDs P1.0, P1.1, P1.2 and P1.3, means we are connecting 4 LEDs. So from that we have to write assembly program to blink 4 LEDs continuously which are connected to port P1. These 4 LEDs are connected to port 1.0, 1.1, 1.2, 1.3, 1.4. Sorry, 1.3 using that resistor. That is the interfacing diagram. Let us see the flowchart. First is start, then configure port 1.0 to 1.3 because we are using 4 LEDs that is connected to port 1.0 to 1.3 as an output pin. Then load A with 0, that is accumulator with 0, and move to port 1. Then call some delay, and after some delay load again accumulator with 1, that is logic 1, and move to port 1, and again call delay, and you have to call a loop in that. And that is the end of the program.